my name is Miss Lynn. I am one of the chemistry teachers here at North. Over the weekend we gave you some problems to do, some example problems on atoms. They are on page 54 in your notebook. There should be a total of 13 of them, and it is a small flip page. So this is the answers to those problems in detail so that you know how to solve them. So problem number 1. What is the total number of electrons in an atom with an atomic number of 13 and a mass number of 27? So when I look at this problem, you really need to know and have memorized, in order to do this, these two words, atomic number and mass number. Okay, so I know that the atomic number means the number of protons in an atom, and the mass number is whatever in the nucleus of your atom, which is nucleus in your atom, which is the protons plus the neutrons. Both of those are in there. So what I'm asking you in this problem is to know the total number of electrons in an atom. Now, if I know my atomic number in this is 13, then that means there are 13 positive charges in this atom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so those are my 13 positive charges. Now I'm making a neutral atom. It's not an ion, it's not positive or negatively charged, so I need the same number of positives in my atom as I have negatives, and electrons are my negatives. So I need to balance all my positive charges with my negative electrons. I'm just lining up to show you the thought process here. And so when I do them, they all cancel out, they cancel each other out, and I'm left with an overall charge of no charge. An overall charge of nothing in my atom. So when I do that, if I have 13 positive protons, that means I need 13 negative neutrons, or negative electrons. Negative electrons. Electrons are negative. Okay, so the keys to answer this question, you have to know what the atomic number is. That 13 protons are called aluminum. You don't really need to know that, but that is true. And then the mass number is just there to confuse you and mislead you. You don't even need this information at all to answer this question. Its only purpose is to confuse you. And so the correct answer would be A. And if I have 13 protons, I need 13 electrons. All right, moving on from this question. Question number 2. The nucleus of an atom consists of 8 protons and 6 neutrons. The total number of electrons present in a neutral atom is, this is literally the exact same question that you just answered above, except now I'm being a little more sneaky with my information. Again, I'm telling you information that you don't need to know. You don't need to know the neutrons in order to assess the amount of electrons. All you need is protons. So if I know if I have 8 positive protons in my atom, again, 1, 2, 3, 4, 5, 6, 7, 8, then that means I need 8 negative electrons to balance those out. So when I'm making a neutral atom, I need the same number of protons as I have electrons. And again, here is my answer. My answer would be C, 8 electrons. Okay. Moving on at a fast pace so that we can go ahead and go further. What is the total number of protons and neutrons in this nuclide? Okay, we have bromine here. Now, in order to answer this question, you have to know the Nuclide Notation form. So in that form, you have your symbol of your element in the middle, and then this number at the top is going to be what's called your mass number, and the number at the bottom is called your atomic number. Okay, and again, if I'm defining these terms, you need to have this memorized at some point, but my mass number is the protons plus the neutrons, whereas my atomic number is the protons by themselves. So now I'm asking you, what is the total number of protons and neutrons? I'm asking you, what is the mass number? This is literally the definition of mass number. So I'm asking you, what is the mass number of this nuclide, the correct answer is C, 80. You don't have to do any math or anything in order to answer that question. So in order to understand it, you need to know that these things here. All right, rolling down. We be rolling. All right, which atom contains exactly 15 protons? So in order to do this, I need to use my periodic table, and I have to figure out, okay, 15 protons. I'm going to look at what's called the atomic number in order to assess my protons. So I'm going to go ahead and I'm going to look on my periodic table, and it's always this top number, which is my atomic number. And I remember it by atoms are really small, so the atomic number, the atom number, is going to be the smaller one. So if I look on this periodic table, I will see that P, or phosphorus, is the only one that has 15 protons in it. So my correct answer is A, phosphorus 32. Now again, that it's written in hyphen notation, and these are just the mass numbers after it. So the mass numbers are just there to confuse you and make you try and choose the wrong answer. But however, it's just that simple. Go on your periodic table, look up the atomic number. Atomic number is 15. All right, so in order to answer this question, here's what I just said in a summary form. All right, moving along. Which symbol represents a proton? So again, when I'm doing this, it's called Nuclide Notation. I have my symbol here, okay, and then at the top I have my mass number, or protons plus neutrons, and on my bottom I have atomic number, which is just protons. So if I want to know what symbol represents a proton, just one, so the only element on the periodic table that has one proton is hydrogen, so you know my symbol is going to be hydrogen. Now it's telling me I only have one proton, so that's my atomic number. Number of P's is going to be 1, so using another color I'll put my 1 here. And then now my top number is protons plus neutrons, but think about this. I only want a proton. There's no neutrons in this. So what's 1 plus 0? It's going to be 1. So 1 plus 0 equals 1. So my correct answer is A. That's what the symbol of a proton is. 1 for my atomic number, and then again 1 at the top because there is no neutron. So they're going to just go to 0. All right, and then again, this is all summarized down here in words if you want to take a look at it or you're confused, and I'm going to keep on rolling up. Okay. Number 6. What is the total number of protons contained in the nucleus of carbon-14 atoms? So again, this is just the same, similar questions, just worded in different ways. So the total number of protons contained in a carbon-14 atom. Again, all I do is I go to my periodic table, I look up the atomic number, which stands for the number of protons, okay, in my carbon, and that's going to be 6 based on this periodic table that I stole from the internet. Okay, so moving on, this is again the hyphen notation. Again, this is the mass number, not the atomic number, and the hyphen notation. So the correct answer is 6 based off the periodic table. All right, moving along. Which nucleus contains the greatest number of neutrons? Okay, so now we're getting a little bit more complicated. If you're doing this again, this bottom one is your atomic number, top one is your mass number. Okay, so my mass number again is protons and neutrons combined together, whereas my atomic number is just protons. So in order to solve this problem, I have to do some simple math. I have to do my mass number minus my atomic number equals number of neutrons. Okay, so if I do this simple math out, this is how I would do it. I'm going to take for A, 31 minus 16, and when I do that, I don't know, what do I get? I get 15. And then over here, 32 minus 16, I'm going to get 16. Over here, 31 minus 15, I'm going to get, I think, 17. And then this guy over here, 32 minus 15, that would be 17. So, ooh, this is going to be 16. I lied. Okay, so scrolling down just to check my work, I wrote the answers under here. So yes, sulfur is 15, sulfur again is 16, 16 and 17. So my answer would be D, 17, because D has the most neutrons. And I found that again by subtracting the mass number minus the atomic number in each isotope. Alright, moving on down. What is the total nuclear charge of an iron atom? Now, even though we haven't explicitly discussed nuclear charge, we serve as an expectation that logically thinking, the word nuclear is a lot like the word nucleus, right? So when I'm asking you, what is the nucleus charge on an iron? Well, where does all the charge come from in the nucleus of an atom? It comes from the protons. So this is another sneaky way to ask you how many protons are in this atom. So I would go, I'd look at my atomic number. Iron has 26 protons, and since all the positive charge in the nucleus is coming from these 26 protons, then this iron is going to have a charge of positive 26. And that answer is A. And again, all of that is explained in words down here if my verbal explanation is confusing you. Okay, rolling on, number 9. Which nuclide contains the greatest number of neutrons? So looking at this, these are partial nuclide notation. So all they did is writing the mass number at the top, and they've sort of dropped the atomic number at the bottom. So I would say, atomic number, where are you? So which nuclide nuclide has the greatest number of neutrons? Again, we have to do that math. It's the same simple math that we did before, but now instead of giving you the atomic number like the other question did, we have to use our periodic table and look it up. So I think I have them listed here. So we're going to use again our atomic numbers, or the number on the top, number of protons, and we're going to do our simple math. So for A, I would do 37 minus 17. B, it would be 39 minus 19 for my K. And then up here, I'm getting my, for C, 40 is my mass number for argon, minus the atomic number of 18. And then D would be the 41 in calcium minus the 20 protons in calcium. When I go out and I go through and I do my math for this question, and again, it is all written out here for you, I got 20, 20, 22, and 21. So the correct answer for this is C, argon, with 2 neutrons. All right, scrolling down. Number 10. In which atom do both contain the same number of neutrons? So again, you're kind of doing the same math problem, but now we're making it one step harder. Now you have to compare the two. So if I take 20 minus 10, that's going to be 10 neutrons here. 40 minus 18, that's going to be 22 neutrons, so it can't be this one. They do not have the same number of neutrons. Let's see. In this one, copper, now this is a mistake. This should actually be neon, because copper does not have 10 protons. Neon does. So if I do the math on this, it's going to be 10. And if I do this, this is going to be 35. And so it can't be that answer. And then if you go along here, 14 minus 6 is 8. So this is carbon 14. And oxygen 16. 16 minus 8 is 8 neutrons. Okay, so C is the correct answer. It's the only one where both isotopes, and they're not isotopes of each other because they're different elements, but both atoms have the same number of neutrons. Alright, and again, all of this is explained slowly in words if you would like to read it over. Okay, and then now we're on number 11. Okay, if X is the symbol of an element, which pair correctly represents isotopes of X? So in order to answer this question, you have to know the definition of an isotope. And in an isotope, you have the same number of everything, except you have different numbers of neutrons. Okay? And I like to think of them as, you know, some people are a little bit fatter, some people are a little skinnier, so I like to think, you know, some people have a few more neutrons on their belly than other people. And so thinking it like that, I'm starting with the same element. Everything, the atomic number isn't going to change. My number of protons isn't going to change. But the top number, my mass number, will change because my mass is getting heavier or lighter as I lose or gain neutrons. So looking at this, these are both the exact same element, so this is the same element twice. It can't be that answer. If I look at this, my atomic number is the same. That's what I want. My protons didn't change, but then you'll see 158 to 158 to 159. My mass number has increased. So this is going to be your isotopes. Let me look over here. All they did was confusingly switch these around. This one can't even exist in real life. This can't exist because I can't ever have a mass number that's higher than my atomic number. That wouldn't make sense. So this element over here doesn't exist. So the correct answer is B for this one. That's the only one that is a set of isotopes. All right. Scrolling down. All right. Alright, number 12, almost the last one. So a sample of element X, and again, we don't know what element X is. There is no element on the periodic table labeled X, so it's a made-up alien element. A sample of X contains 90% 35 atoms, and 8% X37 atoms, and 2% X38 atoms. The average mass number is closest to. So if you didn't know this, again, this is a reminder, we did talk about it at the beginning of the year, but it has been a while. So the number on the bottom of your periodic table, right here, okay, again, if we have X over here, say X has an atomic number of 10. Okay, it doesn't, but say it does. Based on that information, that is, again, our atomic number. And then say, for example, this was our 35. Well, on a real periodic table, it's not 35. What do they really have? They would have 35.21300, blah, blah, blah. And so what they're doing is this is your mass number, but this is the average mass number for all isotopes. So what they did is they combined all the abundance of the isotopes and they averaged that information to create this number here at the bottom, this whatever it is. So looking at this information, I'm going to go ahead and I'm going to think, okay, my real mass number for this is going to be closest to the isotope that I have the most of. So looking at that information, the one I have the most of is the 90% 35 one. So that is the one that my average atomic mass is going to be closest to. Because I only have 8% of the 37, and I have 2% of this 38 over here. So the one where I have the most stuff is going to be 35. So my number is going to be closest to that. So the correct answer is B. Scrolling down. Alright, it's going to be B35. Alright, and then my last question is number 13 at the bottom, and oops, I meant to delete it off because it's a repeat as one above. So you are done. Yay. I hope this has helped you and go over some of the things that we've been talking in class and test your knowledge. And some of these questions in a different form may possibly show up on some type of exam at some point. Okay, thank you. Bye.